Fibonacci number up to n using recursion. Using recursion. So what is a Fibonacci series? Fibonacci number, the first two values will always be 0 and 1. What will be the next number? The next number will be sum of previous two numbers. So 0 plus 1 is 1. What is the next number? Sum of the previous two numbers. 1 plus 1 is 2. 1 plus 1 is 2. What is the next Fibonacci number? 2 plus 1. 2 plus 1 is 3. What is the next Fibonacci number? Sum of the previous two numbers. 3 plus 2 is 5. Next Fibonacci number? Next Fibonacci number is sum of the previous two numbers. What is sum of the previous number? 13 plus 8 is 21. What is the next Fibonacci number? Sum of the previous two numbers. 21 plus 13 is 34. 34. So these are the Fibonacci numbers we have seen by using the for loop or while loop. That is called as iterative program. Now we are implementing the same Fibonacci set of numbers by using the recursion. Now, to calculate the Fibonacci of n, Fibonacci of 5. Say that I want to calculate the Fibonacci of 5. Now, how Fibonacci of 5 is dependent? Fibonacci of 5 is dependent on the previous two numbers. That is, it is dependent on Fibonacci of 3 and Fibonacci of 4. Fibonacci of 4. How Fibonacci of 3 is we can calculate? We can calculate Fibonacci of 1 plus Fibonacci of 2. But what is Fibonacci of 1? Fibonacci of 1, we know that Fibonacci of 1 is 1 because those are the base values. How Fibonacci of 2 is we calculate? It is dependent on Fibonacci of 0 plus Fibonacci of 1. Sum of previous two numbers. What is Fibonacci of 0? Fibonacci of 0 is 1 because those are the base values, starting values of Fibonacci number. What is Fibonacci of 1? Fibonacci of 1 is 1. Fibonacci of 1 is 1. Now, write that. Write that you have not calculated. How Fibonacci of 4 we calculate? Fibonacci of 4 is nothing but Fibonacci of 2 plus Fibonacci of 3. Fibonacci of 3. So what is Fibonacci of 2? Fibonacci of 2 is nothing but Fibonacci of 0 plus Fibonacci of 1. Fibonacci of 1. Now what is Fibonacci of 0? Fibonacci of 0 is 0. What is Fibonacci of 1? Fibonacci of 1 is 1. Now we have not calculated Fibonacci of 3 also right hand. What is Fibonacci of 3? Fibonacci of 3 is Fibonacci of 2 plus Fibonacci of 1 or Fibonacci of 1 plus Fibonacci of 2. Fibonacci of 2. What is Fibonacci of 1? Fibonacci of 1 is 1. What is Fibonacci of 2? Here I write it in short. Fibonacci of 2 is Fibonacci of 0 plus Fibonacci of 1. What is Fibonacci of 0? It is 1. What is Fibonacci of 1? 1. I am writing it short because of less space and taking as 5. Now, calculate the 5. This is Fibonacci number. Now, Fibonacci of 1 0. Fibonacci of 2. What is Fibonacci of 2? 0 plus 1. 0 plus 1 will be 1. 0 plus 1 will be 1. Now what is Fibonacci of 3? Fibonacci of 3. Fibonacci of 1 is 1. Fibonacci of 2 is 1. 1 plus 1 is 2. 1 plus 1 is 3. Now, right hand side. Now Fibonacci of 0 we know. Fibonacci of 1 we know. Fibonacci of 0 we know. Now what is Fibonacci of 2? 0 plus 1. This is 0, this is 1. 0 plus 1 is 1. Fibonacci of 2. Now, what is Fibonacci of 3? Fibonacci of 1 plus Fibonacci of 2. What is Fibonacci of 2 is 1. 1 plus 1 is 2. Fibonacci of 3 is 2. Now what is Fibonacci of 4? Fibonacci of 2 plus Fibonacci of 3. 1 plus 1, 2 is 3. 1 plus 2 is 3. Now what is Fibonacci of 5? Fibonacci of 5 is nothing but Fibonacci of 3 plus Fibonacci of 4. So 2 plus 3. What is 2 plus 3? It is 5. It is 5. So now you can see that 0 and 1 are the starting numbers. Starting numbers. What is the? This is Fibonacci of 0. Fibonacci of 0. This is Fibonacci of 1. What is Fibonacci of 2? 0 plus 1 is 1. This is Fibonacci of 2. What is Fibonacci of 3? Fibonacci of 3 is 1 plus 1 is 2. This is Fibonacci of 3. What is Fibonacci of 4? 1 plus 2. Fibonacci of 4 is 1 plus 2 is 3. What is Fibonacci of 5? Fibonacci of 5 is 2 plus 3. 2 plus 3 is 5. So we have got 5 plus Fibonacci of 5 is 5. Fibonacci of 3. Fibonacci of 3 is 2. Fibonacci of 4 is 3. Fibonacci of 4 is 3. Here everybody got the concept? What is the concept? Fibonacci of 5 is dependent on Fibonacci of 3 and Fibonacci of 4. Until unless we get the Fibonacci of 3 value, we cannot calculate the Fibonacci of 5. That means Fibonacci of 5 is dependent on these Fibonacci numbers. But how Fibonacci of 3 is calculated? Fibonacci of 3 is dependent on Fibonacci 1 and Fibonacci 2. But Fibonacci of 1, we know that Fibonacci of 1 starts from 1, 0 and 1. So Fibonacci of 1 is 1. But we don't know what is Fibonacci of 2. Fibonacci 2 is nothing but Fibonacci of 0 plus Fibonacci of 1. So Fibonacci of 0, we know that this is the base case. Fibonacci 1, this is the base case. So base case we know 1, 0 plus 1 is 1. So Fibonacci of 2 is 1. Now to calculate the Fibonacci of 3, Fibonacci of 1 plus Fibonacci 2. Now only we have got the solution for Fibonacci of 2. Now you use this solution, 1 plus 1 will become 2. So Fibonacci of 5 is dependent on Fibonacci of 3 plus Fibonacci 4. But we don't know what is Fibonacci of 4. Fibonacci 4 is dependent on Fibonacci of 2 plus Fibonacci of 3. But what is Fibonacci 2? Fibonacci 2 is nothing but Fibonacci of 0 plus Fibonacci of 1. But we know the base values are 0 and 1. 0 plus 1 is 1. So Fibonacci of 2 will be 1. But what is Fibonacci of 3? 1 and 2. What is Fibonacci of 1? 1 is 1. Fibonacci of 2 again dependent on 0 and 1. We know only the base values 0 and 1. So Fibonacci of 2 will be 1. So now what is Fibonacci of 3? Fibonacci of 1 plus Fibonacci of 2. 1 plus 1. 1 plus 1 will be 2. Now we can calculate the Fibonacci of 4. 1 plus 2 will be 3. Now we have got this solution, Fibonacci of 3. Now we have got the Fibonacci of 4. Now we can calculate the Fibonacci of 5. Fibonacci of 5 is dependent on Fibonacci of 3 and Fibonacci of 4. So Fibonacci of 3 is 2. Fibonacci of 4 is 3. Now Fibonacci of 5 will be 5. Fibonacci of 5 is 5. So here you can observe in the diagram itself, this is dependent on this, this is dependent on this, it is recursively calling. Until what time it will call? Until we get the base solution. Until the base solution. Fibonacci of 0 is 1, Fibonacci of 0 is 0, Fibonacci of 1 is 1. You can see that the recursion has continued until it is adding only the last value is either 1 or 0, either 1 or 0. It will again not call recursively because these are the base value for the Fibonacci series. stdio.h. Now I will call this one as Fibonacci, F-I-B-O. In short, I am writing as Fibonacci series of numbers. Now, if n is equal to 0, that means what is the zeroth Fibonacci number? This is the base value. Zeroth Fibonacci number is 0. Return simply the value 0. Now, if I want to calculate the first Fibonacci number, if n is equal to 1, if n is equal to 1, what is the Fibonacci series of 1? Fibonacci series of 1 is 1 itself, because 0 and 1 are the base values. Now you come to the recursion value, other than 0, other than 1, other than 0, other than 1, else, return, FIBO. Now suppose that you want to calculate for Fibonacci of 2. What is Fibonacci of 2? Fibonacci of 0 plus Fibonacci of 1. Fibonacci 1. If I want to calculate for Fibonacci of 3, if I want to calculate Fibonacci of 3, it is 192, right? 192. So, in general, Fibonacci of n is equal to Fibonacci of n minus 2 plus Fibonacci of n minus 1. That is, for example, Fibonacci of 5 is equal to Fibonacci of 3 plus Fibonacci of 4. This is how we write. So here, return Fibonacci of n minus 2 plus Fibonacci of n minus 1. This is the recursive equation. Close the main function. Now, close the Fibonacci function. Now I will write the main function. So in base, int a printer enter a value. I take one more variable I. So here is the value of I. Channel percentage comma address of A. Now what you are doing? You are using the Fibonacci series. So you just display the message Fibonacci series. Of number 5. Now I want to take all the Fibonacci series. Here I will use the formula for I is equal to 0, I less or equal to n, I plus. Now you call this function. Now print as slash n percentage d comma Fibo of I return 0. Since here it is returning integer value, here I am not storing, I am directly printing here. If you want, you can store in a variable and print it as C. Now I am directly printing the value here. Whatever the value is written, it is directly printed here. If you want, you can take another variable as C. Here you can write C is equal to Fibo of I. Then you print the value as C here. Now here I want to print directly as Fibo of I. Now there are two functions in this program. One is Fibonacci function, Fibo I have taken, another is the main function. So whenever you run the program, so main function is always executed first. Now enter A value. So output enter A. Say that A is set. A value is set. So I want to print 10 Fibonacci number. Now this is the message displayed on the output screen. Fibonacci series. So now I am starting with 0. I is equal to 0. I less than or equal to 10. True. So here I have taken as L. Here I have taken as A. So you have to write here as variable name as A is L. Here you have taken N as you have to write L. So here I have taken the variable name as A. You have to take as A. So 0 is less than or equal to 10. Now you are calling the function Fibo. What is I value? I value is 0. So here 0. So n value will become 0. Now if n is equal to 0, then it is 0. Return 0. So 0 comes here. Now what I am doing here? Printf. I am not storing the value of 0 in another variable. I am directly printing here. So printf, what is the value returned here? The value returned is 0. Now this is the formula I have. Now I plus I value is 1. 1 is less than or equal to 10. True. Call the function Fibo of 2. Control this combination. Now I is 1, right? 1. Fibo of 1. The control will come here. What is the n value? N value is 1. Is n is 0, false. Is n is 1, let return 1. So 1 comes here. In this place, 1 comes here. 1 comes here. What I do is I am directly printing this 1 onto the output screen. So what is displayed onto the output screen? 1. 1. Again I plus plus. I plus plus. I is 2. 2 is less than or equal to 10. 2. 5 of 2. 5 of 6. Now n is 2. Is n is 0, false. Is n is 1, false. What is 5 of 2? 5 of 2 is equal to 5 of 0 plus 5 of 1. What is 5 of 0? 5 of 0 is 0. 5 of 1 is 1. What is 0 plus 1? 0 plus 1 is 1. 1 is written here. So I directly written here in the printer statement. 1. 1. I plus plus. I plus plus. I is 3. I is 3. 3 less than or equal to 10. True. Call the function. 5 of 3. 3. Here, what is the n value? N value is 3 now. N value is 3. Is n is 0? False. Is n is 1? False. What is 5 of 3? 5 of 3 is equal to 5 of 1 plus 5 of. What is 5 of 1? 1. What is 5 of 2? 1. What is 1 plus 1? 1 plus 1 is 2. 2 is returned here. 2. So 2 is displayed on the output. I plus plus. I is 4. 4 less than or equal to 10. 5 of 4. 5 of 4. Now n value is 4. What is 5 of 4? 5 of 2 plus 5 of 3. What is 5 of 2? 1. 5 of 3 is 2. 1 plus 2 is 3. 3. Similarly, I plus plus 5. 5 less than or equal to 10. 5 of 5. 5 of 5 will be 5. I plus plus 5 of 6. 5 of 6 will be 5 of 4 plus 5 of 5. 8. I plus plus 5 of 7. 5 of 7 will be 5 of 6 plus 5 of 5 plus 5 of 6. 5 plus 8. 13. I plus plus 5 of 8. 5 of 8 is nothing but 5 of 6 plus 5 of 7. 5 of 6 plus 5 of 7 is 21. I plus plus 5 of 9. 5 of 9 is nothing but 5 of 7 plus 5 of 8. 34. 34. I plus plus 5 of 9. 5 of 9 is nothing but 5 of 7 plus 5 of 8. 55. I plus plus 5 of 10. 5 of 10 is nothing but 5 of 8 plus 5 of 9. 89. So these are the I plus plus. I is 11. 11 is the type 5. So how many numbers they have to take? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it depends only up to 55. Fibonacci of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. When Fibonacci of 10 is 55, when I plus 2 will become 11. By that time, the values are printed onto the output screen. The values are printed onto the output screen.